Hello everyone. Welcome to my talk. Myself, Yash. I will be talking about one of the critical topic within security, that is supply chain security, and we'll try to understand what all are the pain points and why it matters to us. A bit about myself. I am Yash. I'm currently working as an associate software engineer with ChainGuard, where we work on. It's like a cybersecurity firm working towards uh, providing zero CV container images. Addition to that, I'm also a community guy. I like to talk, organize some community events. So I'm a CNC ambassador. And this is my first time visiting Denmark. And up until now, it's been great. The weather has been good, I will say. So yeah, before getting started to our talk, I just want to highlight the point like this. The reason why we all, like you as an audience and me as a speaker over here, have come together is because there has been significant rise of software supply chain attacks in the past. SolarWind was one of the major eye-awakening, I will say, attack that happened due to a small compromise within the build system that basically affected a lot of uh, organization and consumer who are using that particular product. Addition to that, there was a lot of billions of revenue loss within that process. And in the past 5 years, the number of supply chain attacks has been frequently increasing, and we will understand why it basically matters to all of us. So just get started with that. So what does basically software supply chain means? It's just like remember it's same as that of traditional software manufacturing supply chain kind of thing, where but this is with respect to software, where we tend to have a source, where we tend to have a code, source code. Then we basically build that using various dependency. Then we package that and ship it to various artifact registries such as Docker Hub or like any other registry which can be within the air-gapped environment. Then we deploy that into any testing environment from dev to production. But if we see dependency can be a, if we focus more towards dependency has a smaller development life cycle where it can be built the same way. It's kind of a, this is what is the weakest link within the entire supply chain as of now. But in general way, this is what we tend to call as software supply chain. And this is kind of an small example. Consider me as a Golang developer. If I build a package that basically works around scaling up and deploying, scaling down deployment, I can package that. I can create a binary or a Docker image. I can push that to artifact register at Docker up. And at a consumer end, consumer can make use of this particular artifact to either use it in a way as a good friendly project, or he or she within the consumer environment can be a developer who can make use of the same Docker image I worked on and can make something good out of that. It's kind of a loop where we can see the code written by me is being used by someone else to write their own code and publish something. And if anything, if things on my end is been maliciously, if consider me as a malicious actor, and if things on my end has been like malicious and I'm sending that to the consumer, it tends to get followed by a lot of people who are using the same Docker image or kind of artifact that I have published. And due to that, the term I will say securing software supply chain comes into picture. It's just a small, it's just a term where we basically make sure that securing the entire supply chain, starting from the source code management towards deploying thing, is what we call as software supply chain security. And there are a lot of things which are involved within this entire life cycle, I can say, of the build process part. Uh, but yeah, just an overview about what does software supply chain security means. And yeah, once we got a good understanding about what the software supply chain security means, let's consider why it has become, like why it matters to all of us today. If we see in the past, like if I was a bad actor 5 years ago, if I need to infiltrate into an organization, I will try to focus my entire time onto targeting one particular organization in which I will try to get into the production cluster. But today, it's been more feasible because rather than spending my entire time on one particular organization or company, I can basically try to find out the weakest link or the thing that has been used by all of us. And that is basically packages. Now, packages become one of the most, I can say, thing where bad actors or I can say attackers are maliciously like adding the code to it. In the past 3 years, there has been significant increase in malicious package, and with respect to all this, like the if we consider the big Python libraries like Golang, Python, or I can say Java, there has been plenty of main package that we tend to pull tend to have a lot of dependency. Some of them are critical, some of them are very low, but it's in the upstream, it's still present. And as per this is the report where I have been documented based on the Gartner's report, a research paper. Out of the organization who has basically applied for that particular research, 45% of them have basically faced any supply chain attack in a way, I can say, mining bitcoins into a production cluster that happened in the past, and only 6% of them were able to, I can say, effectively manage this kind of attack that had happened and try to mitigate that. But one of the major reason why this attack tends to happen is because most of the commercial code that we all tend to write comes from open source. And open source ecosystem has been fairly a large, been adopted by a lot of us. But people, there are various blind spots within the open source region which have been maliciously like attacked by bad actors, and that has been creating a lot of supply chain attacks in the past. And as we go forward, if I'm talking right now, there will be various other similar attacks that may be happening. There is a website called as Hacker News. It basically states all the list of attacks that happen with the remediation part, but we can see each day by day the attacks have been pretty much growing a lot. So, like, what's the reason behind uh, increasing? What's the reason behind this increase in supply chain attack? One of the reason is dependency poisoning. If we see, if I'm using npm install, it tends to pull a lot of packages, and out of the packages, there will be sub packages which I don't should require, but still they're getting download. I can say fetch within my dev environment, which may be malicious. There is a Boto 3 kind of package, which is like AWS SDK. Uh, that basically tends to have a lot, that has been used by millions, which have been coming from just a GitHub URL. There is no authentication, there is no verification on from where the package has been coming. But in future, if that such package it's been infected or been attacked, it directly get pulled to our main package, because it's just like it's required by the main package, but there is no remediation to that. Second is malicious code injection. This happened a lot in the past, where like with respect to maintainers, the token has been exposed. Bad, like malicious code has been like written down into the Git repository, and that has been fetched within the build process and been delivered to the customers. Then compromised package manager. There also there has been like few attacks that may have happened where the bad actor tried to impersonate the original repository within the package manager, and people were developer like us were make sure we're using that and were falling for the trap of this kind of supply chain attacks. And the last is like the blind spot within the open source project. So like there are various open source projects which have been packaging and shipping container images or binaries or artifacts, but most of them have been properly implementing security, because it's like just as we know, in open source we tend to work and contribute from our own need. It's not like we tend to get forced to contribute. It's a fun way to contribute things, but there are various corner areas where things can get wrong, and that blind spot has never been like worked around or fixed by various maintainers within the project. So let's talk about what's the, like this is one of the attack vectors within the entire build pipeline. If, as we talked earlier, the build pipeline tend to have a source code build, which basically make use of various third-party dependency. Then it packages that, it deploys and run into production. But there are various areas where things can go wrong, and these are the areas where like attackers are trying to infiltrate, or try to get good hands into. And one of the two major things is like injecting bad code at the start, or the dependency. And as I told earlier, dependency is becoming one of the major places, not places, but the major attack center, where everyone around the globe is trying to find packages or dependencies which are easy to exploit and it is easily been pulled within the dev environment without concerning the developer or the entire organization. But there are plenty of others, like at the build state, there will be compromised build system or bypassing CI/CD. At the package level, there can be compromised package manager. In this case, there can be some package manager which are compromised. There was a case study with respect to PyPy repository in the past, where there was a bad actor tried to impersonate the original package manager. PyPy is basically used as a library, basically used to communicate with LLMs. So what happened over there is so at the time of AI, Gen AI, I can say Wave, uh, there was a package manager called as Cloud Engineering and GPT-4 Plus. So attacker has impersonated the real one, and in the backend, they were trying to have a proxy. So whenever me as a developer was trying to pull that code, I was able to talk to LLM, but in the backend, it was just a proxy. But that particular thing was there for a year long, and people were using that without even making sure that that was a whether it's a verifiable source or not. And after a year, it was been found out, it was been removed. But this kind of things still happen, and there will be plenty of other packages in the open source ecosystem that are still been infected, and we over here are still not aware until and unless we tend to take precautions and work towards making it more secure. So these were some of the like craziest hits in 2024. There are plenty of them, but I just need to focus on two of them because one is that Lottie file. So as I talked earlier, Lottie file is kind of a dependency, like package that is basically used to render animation a lot more faster in a web-based application. So attacker, they were so like rather than so Lottie files basically used by crypto like used by web to like to include web animation a lot more faster by a crypto kind of crypto side, mostly towards organizations who are working towards crypto tracker app and everything. So that particular attacker, rather than focusing on that organization, he tried to find out the smallest, I can say, weak link that the company was using. In this case, it was Lottie files. What he did was, in case of Lottie file, it's an open source project. It's a JavaScript package manager. Lottie file, one of the token was exposed by the maintainer, of a maintainer was exposed. The attacker was able to get a hands on that. He made changes to the main repo, added some malicious code to that. The code was trying to basically connect, will tend to ask for a connection to cryptocurrency of the user. But in this case, whenever the Lottie file was getting, like the package manager was getting loaded, as a consumer, if I'm using that, I just get a pop-up, like a cache pop-up. If I click on that, it will try to initiate I can say cryptocurrency connection to the consumer's wallet and try to drain it out and send the entire amount to a remote server of the attacker. And when this was this was there for 1 or 2 weeks. When this was there, there were many people got affected from that. Some of them basically left. I can say some of them tend to lost their entire crypto wallet currencies. And afterwards, this was fixed in the coming, I can say, release. But yeah, this was one of the attack that happened with respect to like focusing towards a dependency area, why it's a weakest link. And then second, there is a Jarka stealer. This is the one I talked about earlier, where in the PyPy repository, people were able to create and mimic the original GPT-4 and Claude AI repository. People were using that. So in this case, what was happening is that particular package, whenever was pulled within the dev environment, it will try to initiate, basically, it will try to download a jar file. That jar file tend to have a malicious Jarka stealer software that once get installed in your developer environment, and as a developer, as a consumer, we are not aware about that, how that basically works. But once it get installed, we can't also mimic or identify when it was installed. But that particular software used to basically click random screenshot of your laptop, collect all the session token, and used to send that over to a remote server. This was there for 1 year, as I told earlier, and it was been fixed. But various developers who are using that, some of their credentials got exposed. So this has been these are one of the greatest hit I will say. In addition to that, there is another famous, I can say, supply chain attack, that is exit utility backdoor. This was with respect to the operating system, where the user could have, this was a critical one, where the user could, the attacker could able to get a server access of the cluster in which our production has been deployed, production environment. So these are one of the greatest hits. Now let's talk about what are the solution around, like, we did talk about how, why it matters to us, why it all matters to us, what all risks it tends to have, and what are the weakest link within the entire supply chain. If we talk about solution, whenever we talk about securing a supply chain, we talk about two things: transparency and provenance. Provenance is kind of a way to, it's kind of a way to verify your metadata, I can say entire build pipeline, and make sure that whatever things which have been getting delivered to me is coming from a right source. And transparency is like kind of things which have been delivered to me tends to have all the list of ingredients, or I can say all the package and dependency which have been originally listed by the upstream repository. One of the project is like SLSA. This basically comes under provenance. So what it does is basically, it's a security framework that basically consists of a list of standards that we should follow whenever we tend to, and this, while building a package, this only is restricted to a build pipeline. As I saw earlier, over here, we have a source, we have build, and we have package section. But this particular SLSA configuration tend to only work for the build and package section. For now, as per the release of version 1.2, in future, they will be exploring more options to how they can secure source management also, and at the time of deployment. But yeah, as of now, it only tends to state for build pipelines. How it basically works is it tends to have levels, from level 0 to level 3. And level 0 is kind of a way where you are not aware about provenance, you are not aware about SLSA, you came across SLSA, you are started exploring about that. Level 2, or I can say build level 1, is like you understand how your build system is working. You tend to package things. You know how my package or my Docker image is getting processed or been packaged, and how I can apply provenance on top of that. In L2, so whenever we talk about levels, each level is kind of a way to get more secure, to have a more secure tamper-proof build system. It's not easy to implement all of the levels, but initially you tend to initially you need to provide, I can say, take some efforts on implementing this, but once it has been implemented, you tend to have a tamper-proof and bulletproof, I can say, build system, which can't be infected by any of the outsider, I can say, attackers. And then we, like, if we talk about level 2, it basically tends to state like you should have a self-hosted runners kind of, if you are using GitHub Actions, you can have a self-hosted runners. You should have multi-factor authentication system implemented within your build environment. People who are using, who are basically building things should only have access to the logs if they have permission. So least privilege access comes into picture. Then in level 3, it's like once you attain level 2, reaching level 3 is way more easier, because here you tend to basically focus more towards isolate environment. You try to cut short you will try to cut short network configuration which are not required at your build time. You will make sure that 2% review is been required before merging any PR request. So this all things comes under SLSA. I have an example over here. So this is with respect to a small web development team, but it vary from teams to team. So let's consider a organization tend to have a small web development team. In level 1, what they will try to do is they will try to understand how the entire build system works. They will try to basically understand their CI system, the things that are getting into the build. For example, if I'm building a Docker image, I will make sure that these are all the packages which are getting into my build system, and this is what I'm getting as an output, which can be handled quickly by the small team. In level 2, you can move towards adopting a more trusted CI/CD provider. It can be GitHub Actions if you're using, and addition to that, you can make use of Cosign. Cosign is a tool we will talk in further slides. But yeah, making sure you have a dedicated GitHub CI system. In this case, it can be GitHub Actions. It's level 2 prominent SLSA compliant thing. Then in level 3, you need to isolate your build, as I told earlier. Here, you can focus on implementing your own isolate GitHub runners within your build pipeline. Have multi-factor authentication. People who are only able to, people who are developers and who are building packages, they are only able to view and access the logs. And then there is no level 4. The level 4 is kind of an abbreviated, or I can say a delusional level, where you all can, once you attain level 3, it's way more bulletproof for you all to consider your build system to be way secure. And level 4 is just a way to add some additional implementation like least privilege access, or making sure you are using any policy enforcement tool with respect to your organization. So it's like a way, it's just a top-up of level 3, where once you reach level 3, you are good to go with all the security measures you are working towards. Then once we talked about like provenance, let's talk about transparency. And for this, SBOMs comes into picture. SBOM basically stands for software bill of materials. Just like you have food ingredients, like being a health conscious guy, people tend to follow entire food ingredients whenever they eat food or they tend to purchase things. In the same way, if I'm a consumer, I should be well aware about things that are delivered to me and what all things it tends to have. If I'm having a Docker image, I should be aware about all the packages, all the dependency that particular image has, so that whenever I'm deploying or I'm building things, I'm well aware about things that are getting deployed. So just like food labels tends to have ingredients, SBOM tends to have dependency. We tend to have nutrition facts, same way we have versions. On the left, we can see SBOM tends to have all this further, like if we talk about SBOM, it's just like a JSON format or YAML format document, where we can see an entire list of things. It tends to have a lot of information, such as licensing information, what all license that Docker image tends to have, name of the software components. In this case, it can be dependency. If I'm using a web app which has 4 packages, the name of component will be the 4 main packages, and then the dependency relationship will be all the packages that come under the 4 main package. Then it will be have name of author. In this case, it will be me because I'm creating the SBOM. And then supplier's name. Supplier's name is like the tool that you are using to create the SBOM. And that's all. And apart from that, all the other small detail like timestamp, open source components, and all. So if we move further, there are 3 primary formats in which SBOMs are being created. First is XPDX, second is CycloneDX, and third is SWD. Like all of the 3 tend to have the same output, and they work around the same criteria on generating SBOM, but the use case matter. If you are into finance or risk management, you will make use of CycloneDX. If you are into security kind of a guy or compliance, you will make use of XPDX. So based on use case, the project differs, but at the end, the output that you tend to get will be the same. It doesn't matter if you have different kind of output, different kind of tool, the output will be the same. So let's have a small demo on understanding how SBOM basically works. I have a demo prepared. Yeah. So, yep, is this visible? So this is a Docker file, a small Docker file, where I'm using Wolfie base as a base image. I'm just adding Cowsay as a dependency, which basically runs, which have an entry point, and it basically comments out I love FOSS. So if we see, let's build the image first. Oh. OK. In my case, since I had the base image existing in my Docker desktop, yep, the image creation was easy. But in your case, it will matter because based on the image, it will take more than 30, 40 seconds to build the entire image. But once the image is created, with the help of tool like Fike, you can basically, just a minute, yeah. Yep. So in this case, we are talking about the supplier's name. So Psych is like an open source project which is basically used to generate SBOM. There are various other tools also. Gripe is also one of the tools to generate SBOM, but it's an open source project, so you can refer any of them. And then we are specifying a Docker image, which we recently built. The output should be in XPDX JSON format. So here we are making use of XPDX as a standard primary format for our SBOM. You can make use of CycloneDX also in your scenario. And then we are basically storing that into a readable SBOM, a JSON file. Once I execute this particular command, see, over here, it will try to so the tool will try to go through each Docker file build image layer and try to understand what all packages that particular image has. And if we see the output over here, see, this is the idle output we tend to see whenever like the command gets executed. We tend to have the name of the tool. The creator is basically the tool Psych. And then we have packages. If we say at the package, so these are all the package that the Docker image Wolfie base tends to have. And we can see over here, APK tool is a package which has been there in a Docker image. It's coming from Wolfie. Wolfie is kind of an open source project. So the supplier is Wolfie, and also tends to have all the information such as the license part, it's GPL license. Addition to that, it also refers to any external reference of that particular package with some other packages. So in this case, since APK tool is been built by Wolfie itself, you will see this abbreviated, I can say, reference locator. But if you use any Golang image, upstream Golang image, here you can get a link to any external dependency on which the APK tool will be present. That's how it works. If you go below, you can see BusyBox is another dependency that a package that our image tends to have. In the same way, it's been supplied, built by Wolfie itself, and it also tends to have all the licensing format. And as we know earlier, we did add APK Causa as an additional package on top of our Wolfie base. We can also see that below over here, addition to CA cert builder over here. So this is the additional package that we deployed, but it's also coming from Wolfie itself. So if we do this for any upstream image, you can also get all, like, upstream image tend to have unnecessary dependency and packages also. So you can cut short that based on your use case and based on your study, you can make sure the required dependency has been packaged in your Docker image. And yeah, that's how easy it's to create an SBOM. Further, like whenever SBOM is getting created, you can basically create this SBOM at the early of your build. Like once you build your artifact, and once you package that, you can create early in your life cycle about the SBOM. Once the SBOM, I can say, once the thing has been published, you can basically verify that Docker image with the SBOM that you have, and make sure that whatever thing that is getting delivered to us is been same as is expected as same of the one we saw earlier, the SBOM that we are talking about. And then, yeah. So once we talk about SLSA and SBOM, so SLSA basically help us understand how the artifact or how the package was built. And SBOM basically help us understand what all things your package or your artifacts tends to have. Let's now understand who basically built that package or Docker image. Because these three are the main question whenever, these three are the main thing we tend to see within a within any package that we get delivered to us, who built it, from where it was built, and what all thing that package tends to have. Sigstore is the project that basically help us understand who built it. It's one of my favorite project. It's been maintained by OpenSSF Foundation. It's an open source project. OpenSSF Foundation is a parent or is a child dog of CNCF Linux Foundation. And this has been built by some of my ChainGuard founders and Google team, and now it's been open source. So how this basically works is, Sigstore tends to have three components: Cosine, Flushio, and Record. So Cosine, the ideal theme of Sigstore is having a keyless authentication system. So Cosine is basically used to sign any artifact, any README, or any Docker image. And Flushio is the tool under which the certificate are being issued, short-lived certificate. And Record can be considered as it's not a database, just refer to a database where all the logs are stored. So if you want to get a good refer any logs, you can go and check on Record. So Record is kind of, you can host Record locally in your environment also, because people over here may be having air-gapped environments where things should be within your network and within your ecosystem. So you can deploy Record private, like within your environment, and try to refer Cosine to make use of that particular Record as a private entity. And yeah, this is how the entire architecture of Sigstore looks like. So if we see Cosine, yeah. So with the help of Cosine, if I'm let's go to the earlier example where I, as a Golang creator, if I create a Docker image, I will sign that using Cosine. I can generate my private and public key, or I can directly authenticate it using OIDC Connect provider such as Google, Microsoft, or GitHub. Once I sign that particular artifact, that signature will be present on the Docker Hub. So whenever I'm saying signing the artifact, it's like having a digital signature onto my Docker Hub registry. Then that particular certificate issuing part has been done by Flushio, by basically try to authenticate with any OIDC provider. In my case, I will make use of GitHub. And then all the logs of that particular like signing part has been stored within Record. And this is simple as architecture about Sigstore. I may say it's a bit complex, but the entire end-to-end workflow of playing around Sigstore is way more easier. So yeah, I will just have a demo around how we can basically sign images. By the way, you can also sign readmes. Yeah, with the help of cosign, there are various like possibilities with cosign. You can also sign SBOM using cosign, so that as a consumer, if I'm seeing the SBOM, I can validate the SBOM is coming from a trustable source. Then you can and once you basically sign your artifact or Docker image, let's try to understand how you can integrate with Kyverno. So let's talk about it in the demo. Yeah. So this is basically a Docker file, and this is a main.go. This is basically an like function that basically runs an HTML command, nothing else. So in the Docker file, I'm making use of chain guards go lang image. So we don't have unnecessary dependency. It's minimal as required. We are copying the main.go file. We are building the binary, and we are outputting that binary in outs like in a server out directory. And we tend to have a multi-stage build where we are basically copying the same binary which is stored within the out directory, and we are copying it to server. This is a simple Docker file where we are just kind of running that particular image binary in the Docker image. So let's understand how we can implement Sigstore with this. Yep. Docker. Sophia. So let's build the image in this scenario also. Yeah. So in this scenario also, since the Docker image was pre-present in my Docker desktop, it basically was easy. Like the build was very easy. Once the Docker image has been built over here, as I can see, my NDC web like Sigstore image is present. It's like just let me run that. Yep. Yes. Just I have not pushed that, so let me push that to my. Yep. So once I push that particular image in my Docker registry, we can see that over here. Yep, over here. Yeah. So over here, there is no signature as of now. And if you are using that, you can't authenticate whether it's coming from me or not. In a bigger open source project where things run on the container, there should be a .signature file from which I can basically verify that this has been coming from a trustable open source project. Now, this can be done with the help of cosign. We can make use of cosign over here. So this is the command. Just like cosign tends to have a lot of commands, like you can create your private key and public key. You can basically sign your Docker image using your private key, and then you can share that public key in your README so that other consumer can validate that particular Docker image with the help of cosign. So here I will directly sign this particular image. It will try to ask me for my, like, it will try to open a, as I told, it tends to make the OIDC connect a provider. So it will try to ask me through which particular entity I should assign this particular Docker image. I will make use of my GitHub. So once this has been, so this entire project has been self-hosted by the open source community. So this is what the output is for us. Over here, we can see the image has been signed. Log entry has been, and this is the index through which we can in the record, since it's open source and community driven. In record on this particular index, we can find entire log. I can show that also. So if we go back to our Docker desktop, just a minute. So you can see there is addition of SHA file, .sig file. This is what meant to be my digital signature. And this is basically a metadata of myself and the image I have worked on. So it will contain my email and the person, basically the supplier name, supplier name as me, who basically created Docker image. And when I make use of cosign verify command, I can also verify that. So yeah, in this command, what we are doing is, since we didn't make use of our personal private key or public key, we did make use of OIDC connect. Like we made our signature with the help of GitHub. We will use, we will verify that using like the certificate identity will be my email address, which is been associated to my GitHub, and the authority OIDC certificate authority will be GitHub, and the image name which with the image which I basically recently signed. Once I run this particular command, yeah, it will see. It did check in the record. It went cosign went to record, try to validate the logs. It makes sure that the cosign claims were validated. It came from a trustable source like me. And further, if we see, this is the like the log output we tend to get, where it basically showcases our Docker image from the Docker image reference, the body of that particular the metadata. This can be encrypted. This is encrypted, so we can decrypt that also, and the person who basically issued this particular Docker image. So in big, so if we consider open source product like K8s, it tends to have a lot of containers or API gateway. So we can easily identify that the image we are using is coming from a trustable source by just verifying it with the help of cosign. And this has been implemented. It's a graduated project within open source foundation, and it's been used a lot by a lot of organizations in production scenarios. So simple as that, and we can also use record. So yeah, as I told earlier, we can make use of this log index. This index is basically kind of a reference we can refer to within the record. So once, if we copy this particular log index over here, see, this particular log entry is been present within the record as a record, and this is what we tend to get once we tend to sign the entire Docker image. So since it's open source, we can also validate any logs that is going through the, I can say, within the record. So in a good way, we can also verify a container using cosign, and also verify the logs within record to make sure they both match and the image is coming from a trustable source. So yeah, that's all with this particular Sigstore demo. And now, let's understand how can we integrate Kyverno on top of that. So Kyverno, anyone over here know Kyverno? So Kyverno is an open source project. It basically is a policy enforcement tool within your K8 cluster. So it works around, it works with K8. So what happens is, whenever in Kyverno, you write policies, cluster-wide policy. For example, if you want in your K8 cluster only images from like specific registry should get deployed, that can be handled with the help of Kyverno. It's a great tool. It's been also graduated tool where you can write down policy and specify any pod or deployment coming from anywhere in the entire namespace should come with a particular the image, the deployment image should come from a specific entity, or I can say registry. And if it is not, it will block the deployment. And unnecessary deployment won't pass through your entire K8 cluster in any namespace. And that way, you can prevent like unnecessary or non-trusted Docker image to basically don't get deployed within the cluster. And Kyverno tend to have a great documentation around Sigstore. So we got an understanding about how to sign container images using Sigstore. In my scenario, I have signed that particular Docker image NDC web, and anyone over here can go and verify that. Simple as that. But in case of production, if I'm deploying the same in production, how can I make sure that the image is coming from a right trusted source? I can manually go and verify each and everything, or check each deployment image is coming from a trustable source. Here, Sigstore and Kyverno has worked together and created a policy. This is what I'm talking about. It's a kind of a YAML within like in K8's native term, everything is basically YAML. So you need to deploy this kind of cluster-wide policy where you basically specify that the name of the policy is check image, and you specify the rules for that. So this particular policy will only look for pods, and it will try to understand, like, see if the image or the pod is getting from this if it's coming from gscr.kyverno registry. We can share a public key over here. It will validate itself if whether it's signed or not, if it's coming from a trustable source, and if the output comes to be yes, it will make sure the deployment tends to go into, it will try to deploy the things. And if the image is not been signed properly or it's not coming from trustable source, it will block that particular deployment and it won't deploy. So in a way, once you build your Docker image, you can also test that into production with the help of Kyverno. And there are a lot of good documentation around this. If you are not familiar about Kyverno, do check that out. It's a great way if you are deploying your like your workload onto K8s, a great way to basically enforce policy, and a good project also to contribute. So yeah, this is what demo tends to look like. And a good part is like you can also integrate Cosign and SBOM within your GitHub CI. There are various use functions which you can use to automatically sign your artifacts and basically create SBOM out of that. Also sign the SBOM with your public or private key, and also save that particular SBOM into an artifact registry. So anyone can go and validate whenever things go wrong. So yeah, so once you tend to implement all the, like if you are good with SBOMs, SLSA, and Sigstore, once you start implementing this into a regular workflow, this is how your build process will tend to look like. You have a source code which will, if we talk about source code level, proper least privilege access should be given to developers. You can make sure that. Then we can, as I told, SLSA basically works on build phase. By following all the levels from level 1 to level 4, you can make sure that your entire build system will be way stronger and secure. And reaching at that level is kind of a, not tedious, but a kind of huge workload, initial workload that you need to give, but the end result will be definitely way more brighter. Once you, so let's consider I'm building a Docker image. Let's consider I'm building a Go image. I have a source code. I follow all the levels and checklists the SLSA tends to have, like having my own separate GitHub, isolate GitHub runners, having reproducible builds, multi-factor authentication. And by following that, whatever artifacts will be produced after the build phase, that I can sign using Cosign. I can automate that using my GitHub runners or any script. Once the once the artifacts are signed, all the data entry and the key, like anyone can go and verify within the organization whether it's coming from the proper developer or not. Then we can create SBOM out of that, because once you sign your container image, it have a digital signature which anyone can validate, and then you can create SBOM, and you can make sure that limited things are present within my Docker image, and that all things have been delivered to the consumer. And then consumer, or I can say I can run that into a secure runtime environment. In this case, it can be my prod cluster or my dev testing environment. Over there, I can enforce policy using Kyverno and OPA. OPA is similar to Kyverno, but I can say it functions the same way, but Kyverno is way more graduated. People are referring more. It's been used in production. So, and then with the help of policy enforcement, I can make sure container image with verifiable tag and coming from verifier source are only deployed in my production cluster or dev environment. And once that is done, I can basically make sure I can basically, and also at the end stage, I can validate all the SBOMs. Like in earlier over here, we generated a SBOM. Once the deployment is done, we can also validate again back, making sure that whatever things are getting deployed is like same as what we expect, and it doesn't differ. So this entire pipeline is basically secure, and you can also validate that with automations and SLSA, making sure that whatever things are getting delivered are delivered from a trusted source and not coming from an malicious or bad actor. Simple as that. So what's next? Let's talk about some practical suggestions. So whenever we talk about supply chain attacks, one of the reason is like not following proper security measures, not having proper security policies of access. I will make sure to have a good understanding about SBOM and how SLSA works. Play around with them. Try to integrate that as early as possible within your developer lifecycle, like around build part. Enforce least privilege access. Make sure limited access are given to developers. Access within your environment should be like this. Basically focuses on the topic of having shifting left. It's kind of an architecture, like kind of a term basically used towards having least access within DevOps ecosystem. Then discover CVEs and make sure CVE is kind of any package can have some malicious code. CV basically help us to understand and remediate that for the common vulnerability management. As soon as you are able to understand this particular package has this critical vulnerability, try to remediate that. Control your admission runtime. In this case, try to have org level policy. If you are deploying on cloud, you can make use of RMA permissions. But if you are deploying on, I can say, a production cluster, you can enforce Kyverno. And then make sure that after implementing all this, the blast radius for all of you will be very less. The chances of any attacker infiltrating into your system will be way more less as compared to earlier, where you are not having proper security protocols. So yeah, that's all. So let's move towards conclusion. So make sure that beware about things to use within your supply chain. Make sure that you should make sure that whatever things you are pulling are the one which are required, and unnecessary dependency should be like removed or eradicated. Integrate security into your software as soon as possible. Try to play around with SLSA and SBOM, understand it better. The official documentation and of the open source project are way too good. You can also tend to have various case studies around that people or who have implemented that. Go through that, read about it. And if there is only one thing I will like you all to remember from my talk, it's like security is no longer an afterthought. It starts from your first commit. Make sure that whenever if you, even if you have not enforced security policy, try to do as much as early as possible rather than having a post-deployment session where if everything is gone, if you have been attacked, then you will try to work around fixing that. So yeah, I hope you had some great learning from my talk. All the resource, I prepare a list of resources I basically showcase in the talk. It basically consists of all the course, I can say, kind of a reference point for you all to understand SLSA, Sigstore, and SBOM, and to have a good play around with that. So yeah, that's all. Any questions? Thank you.